You ever stop and think about all the invisible stuff that just works to make our world go round? You know, behind the food on our shelves, the products we use every day, there's this hidden universe of industrial machinery chugging away 24/7. Well, today, we're going to pull back the curtain on one of the most critical and most unseen of these jobs, cleaning up the absolutely massive mess that's created by the food we eat.
Right, so every single product we buy has a footprint. And for the food industry, a gigantic part of that footprint is water. From the steak on your plate to the yogurt in your fridge, making all this stuff generates a colossal, unseen river of contaminated wastewater. And, well, it has to go somewhere.
Just to give you a sense of the scale we're talking about, get this. A single large poultry plant, one that processes around 400,000 birds, churns out 2.3 million gallons of wastewater every single day. That's enough to fill more than 3.5 Olympic-sized swimming pools. And remember, that's just one plant.
And it's definitely not just a poultry thing. Nope, this problem stretches across the entire food industry. We're talking beef abattoirs, massive seafood processors, even dairy plants making things like yogurt. They all contribute to this enormous flow of water that's just loaded with all the byproducts from processing and cleaning.
So what's actually in this water that makes it so bad? I mean, it's not just a little dirty. It's a complex soup of organic materials that needs some serious treatment before it can be safely put back into the environment. Let's take a closer look at the main culprits, the industrial gunk, if you will.
First up is something you're probably, and unfortunately, familiar with: fog. It stands for fats, oils, and grease. Just think about the stuff that clogs up your kitchen sink drain. Now imagine that on the scale of thousands of cattle or millions of pounds of shrimp. It's a massive headache, both for operations and for the environment.
The other big problem is something called TSS, or total suspended solids. Basically, these are all the tiny particles just floating around in the water. Things like proteins, little bits of feather, grit, you name it. This is the stuff that makes the water all cloudy, and if it's not removed, it can really harm aquatic ecosystems by choking out the oxygen. And this slide, wow, this really puts the problem into numbers. Just look at this. The raw wastewater coming out of a beef plant can have a fog concentration of 6,500 milligrams per liter. Now, to put that in perspective, the wastewater from your house might be around 100. So yeah, this isn't just dirty water. It's practically a thick, contaminated slurry that your local treatment plant is absolutely not designed to handle. Okay, so when you're facing a problem this huge, you need a seriously clever solution. And it turns out, the best answer isn't just about cleaning, it's about recovery. It's a really elegant process that's actually based on some super basic physics. So here's the million-dollar question, right? How in the world do you separate literal mountains of fog and TSS from millions of gallons of water day after day in a way that's not only effective, but also doesn't break the bank?
The answer, believe it or not, is bubbles. Billions and billions of microscopic bubbles. The technology is called dissolved air flotation, or DAF for short, and it is just a brilliant way to use physics to solve a very messy biological and chemical problem.
Okay, so here's how it works. A stream of water is put under intense pressure with air, which basically forces the air to dissolve right into it, kind of like the carbonation in a soda bottle. Then, that super pressurized water is shot into the main tank. The sudden drop in pressure makes all that dissolved air rush out of the water, creating this amazing cloud of tiny, tiny bubbles. Now, these microbubbles are the real magic here. They latch onto all the particles of fog and TSS. They basically act like tiny little life preservers, floating all that gunk up to the surface where it forms a thick layer of sludge. And this picture shows you that final step perfectly. Once that blanket of gunk is formed on the surface, a mechanical skimmer, just like the one you see here, comes along and just scrapes it right off the top. What's left behind is much, much cleaner water. It's just an incredibly effective way to physically separate everything out. So that's the theory. But how do these systems actually perform out in the wild? Let's take a look at a few case studies from different industries to see these DAF systems, these wastewater warriors, in action. Okay, so here we are at a beef abattoir. And just look at this thing. This massive piece of machinery is a DAF system built to handle almost 1.9 million gallons of wastewater every single day. You can really see the sheer scale needed to even begin to tackle this kind of industrial output. So, the big question, does it work? Oh yeah, It works. The system took that water with the sky-high 6,500 milligrams per liter of fog and knocked it down by 85%. And for the total suspended solids, it managed a 75% reduction. That is a huge, huge step in cleaning the water up before it goes on for any further treatment.
All right, now let's jump over to the seafood industry. This sleek-looking DAF unit is installed at the largest processor of Pacific cold water shrimp in the entire world. The challenges here are a little different, more grit, different kinds of proteins, but the basic idea is exactly the same.
And the results? Just as impressive. The water coming in had 2,000 milligrams per liter of total suspended solids. The water leaving the DAF system, less than 100. I mean, that's a reduction of over 95%. That's what allows a plant like this to meet its super strict discharge requirements.
But hold on. The story doesn't end there, with just cleaning water to meet some regulations. There's actually a fascinating and really profitable twist to all this. It's not just about getting rid of a problem. It's about turning waste into something valuable. Let's go back to that poultry plant, the one making 2.3 million gallons of wastewater every day. All of that FOG and TSS that gets skimmed off the top, well, it has to go somewhere. And you might just assume it gets hauled off to a landfill, but that's not what happens.
And here it is, right from the case study. The skimmed solids, all those fats and proteins are cooked down and concentrated into an oily product which is sold to a renderer. Did you catch that? Sold. This isn't waste anymore, it's a commodity.
So this is really the triple payoff of this amazing technology. First, it protects our rivers and streams from pollution. That's huge. Second, it lets these essential food processing plants keep running by meeting their environmental permits. And third, it literally transforms a costly waste problem into a product they can sell, creating a whole new source of revenue. It is just a perfect example of smart, sustainable industrial design.
Kinda makes you wonder, doesn't it? As you go about your day, what other invisible machines, what other elegant solutions are just quietly working behind the scenes, solving the incredibly complex challenges of our modern world? What other problems are being skimmed right off the top?